So we are going to work on tutorial 1, sheet 1, both part 1 and 2. It's under units. If you go to units, unit 1, under unit 1, introduction and linear algebra 1.
Tutorial 1, part 1, tutorial 1, part 2.
Part 1, introduction and linear algebra 1.
Yeah.
And then you go to tutorial introduction linear algebra 1. And then you can find both tutorial 1, part 1 and part 2.
Okay, ma'am.
Have you found it?
Yes, ma'am.
Yes, ma'am.
Okay. So what we are going to do is we are going to cover only 1 or 2 questions from tutorial 1. And then we are going to solve the exercises for which we didn't have time yesterday and the day before yesterday. Okay. So again, this is an online session. This is the second part of the tutorial when we cover the questions for which we didn't have time on the first part of the tutorial. Please, someone, would you mute your microphone? Please, someone, would you mute your microphone?
Start.
Hello, would you please mute your microphone because we can hear all these noises and it's very disturbing. All right. Okay, so let's start with tutorial 1, part 1. Tutorial 1, part 1. Question 8. Question 8. Okay. What are the 5 steps of data science? What are the 5 steps of data science? Can anyone tell me? Guys?
Asking the right questions, then obtaining the data, then exploring the data, modeling the data, and visualizing the data.
Communicating and visualizing the result. Very good. Thank you very much. These are the 5 steps of data science. Okay. This is an easy question, but it might come during the exam. So please learn these so that you gain marks easily. Okay. So please don't lose marks with this easy question, right? So again, the 5 steps of data science are asking an interesting question, obtaining the data, exploring the data, modeling the data, and communicating and visualizing the results. Okay, so please remember these 5 steps. Okay, the next one is again very important, very likely to come in the exam. That's why we are discussing it. Exercise 10 on the same sheet, same exercise sheet. Exercise 10.
Wait, sir, can you please repeat it once again? 5 steps.
The former one?
Yes, 5 steps of data science.
Okay, so again, the 5 steps of data science. Asking an interesting question. Asking an interesting question. Second, obtaining the data. Obtaining the data.
Okay.
Exploring the data. Exploring the data. Modeling the data. Modeling the data. And communicating and visualizing the results. Communicating and visualizing the results. So these are the 5 steps of data science. Please remember these in the exam. Okay, so please don't lose marks with this easy question. Okay, the next exercise is exercise 10. Identify the level of measurement for the following. It is again a very important question. That's why we are covering it. now, and please expect it on the exam. So, identify the level of measurements. First of all, could you list me the levels of measurement?
We have four level of measurement.
Nominal, ordinal,
Nominal, ordinal.
Interval, ratio, nominal,
Very
and
good.
ordinal.
Very good. Thank you very much. Nominal, ordinal, interval, and ratio. Very good.
Ratio.
These are ratio. These are the four levels. Very good. Okay. What does the nominal level mean?
Nominal is all about the category of something, or
Yes. Category of something, exactly. Whether it belongs to a given set or it doesn't.
Order doesn't matter in that case.
Yeah, we can't order.
Yeah.
We can't. Ordering doesn't make any sense. Okay.
it's described by names.
So what mathematics can we perform here? What operations, mathematical operations can we?
Addition,
Sets.
Only
subtraction.
we can't. We can't.
No,
In this
sets.
level, we can't. In the nominal level. All we can do.
Equality.
Equality ends membership.
Equality.
Thank you very much. Exactly. Equality. So we can tell that these two data are equal and set membership. In other words, to say whether this thing belongs to this set or it doesn't. Yeah.
How come we set membership in nominal level? Can you please explain this?
Like we can tell whether it belongs to for example, we can say there is a name, a female name. So we can tell that this belongs to the set of female names. Okay, but we can't order female names, which one is better or which, of course, for us, but it's subject, it's not a real ordering. Okay, so there is no ordering in female names or in nationalities. Okay, if we list the nationalities of people, we can't order them. Who is better, who is not, anyone equal. Yes, so every nationality is important. Okay.
Does it mean all the classification problems are nominal?
What do you mean by classification?
Classifying whether the iris data set we classify flower is of this type or this type.
Yeah, because that basically means to which set it belongs to.
Yes.
Yeah, that's fine. But ordering doesn't make any sense. Ordering doesn't make any sense. Okay. What is the center of the data? What does in general mean, kind of center of the data? Usually, what do we think of? What do we think when we are the center of the data? We usually mean the mean or average. Okay, in this case, nominal level, what do we use to characterize the center of the data?
I think mode.
The mode, exactly, the mode, that is the most common element. Okay. Why is it that we can't calculate the mean? What is needed to calculate the mean or average? What is
quantitative variables?
Yes,
numericals.
We needed to add the data, but in this case, addition doesn't make sense. Okay, so it doesn't make any sense to calculate the mean in this case. So it's the mode. Okay. Now, next level is ordinal level. What does that mean? What does it differ from the first one?
Provide rank ordering like
Rank,
1, 2, 3,
Very
rank
good.
A, rank B, rank C.
Yes, which means we can order things. We can put something in order. Okay. And this is what is this? Strange noise. Okay, so this is the mathematical operation. What we are saying, ordering or comparison. Okay, again, subtraction, it doesn't make sense. So difference doesn't make sense here. That's why mean is not possible. What do we use as the measure of the center? Of course, we can use mode as in the former level, but what as?
Median.
Median, exactly, median. Yes. Okay. Next one is interval level, as you said, interval. What's new in this compared to the former ones? Interval.
You can perform mathematical operations such as subtraction and addition.
Very good. Exactly. Yes, we can introduce subtraction and addition, which means differences of data points make sense, right? So we can interpret the difference between two points, data points. Okay, which means what is the measure of center? What can we add to mode and median?
Mean.
Mean. Yes, mean, exactly. Very good. What does the data set have here as opposed to the former one?
Equal interval ordering.
Yeah, and what else, which in the former level we don't have?
There is no any natural zero.
Not have a natural zero.
Exactly, we have a natural starting point or zero. Yes, exactly. Okay, and the last one is the ratio level. What can we say about this? What is allowed? What can we do?
All mathematical operations.
All mathematical.
What mathematical operation can we?
Addition to the
Division,
previous ones, we can
Addition, subtraction.
but we can do
everything which we could in the former levels, right? Everything which we could in the former levels, and in addition, we can do division. Division.
Yes.
That's why the name ratio, right? Division or multiplication makes sense. Okay. Now, after this, now let's do the exercise. Exercise 10, identify the level of measurement for the following. First one, the teacher of a class of year 6 records the letter grade for an English test for each student. So the teacher of class of year 6 records the letter grade.
Maybe ordinal.
Why?
The grades, I think, grade A, grade B, there's an order between them.
Yeah, there is an order between them, exactly. Because what can we say? Which grade is better than the other?
Yes.
For example, what grade is better than?
Maybe we can say grade A is better, maybe grade B.
Yes. For example, exactly. Grade A is better than grade B.
So it's ordinal, right?
So we can order them. We can compare them. So it's an ordinal level. Why can't we go further? Why can't we say that's it interval level? Why isn't it an interval level? What does
grades cannot be
Can't measure.
in intervals, right? Grades cannot be placed in intervals.
Yeah,
they can.
What is
this letter? They're qualitative, not quantitative.
What doesn't make sense?
Like the difference between the C grade and B grade is not the same as the difference between B
Very
grade
good,
and
exactly. Very good. The difference, making the difference.
Hello, there is comparison between the grades, though. That's why.
We can compare the grades.
Yeah,
okay.
yeah.
So we reach the ordinal level, but we can't subtract them. What does A minus B mean? Right? B minus A. And even if we say something, it might not be the same as C minus B, right? So difference doesn't make sense. That's why we can't go further, but we stop at the ordinal level. So this is ordinal level. Next one, part 2. The teacher of a class of year 6 records the percentage that each student got correct on the last maths test.
I think this is continuous
ratio level.
Why is it a ratio level?
Because we can perform everything on the percentages.
Exactly. If, for example, a student got 80% and another student got 40%, does it make sense saying the first student got twice as much percentage than the other one? The first student got 80%, the other one 40%. Can we say that 40 is twice as much as 80 is twice as much as 40?
In terms
Yes.
of percentages, I don't think so.
We can because it's
Yes,
double,
yeah.
right? It's
Okay.
double.
Okay.
So that's why it's a ratio, because this kind of division or ratio, forming the ratio, makes sense.
Okay, got it.
Okay, then the exercise, part 3, the teacher of a class of year 6 records the height of each student. Records the height.
That's common category, so that would be nominal.
Records the height.
Again, ratio.
Interval maybe.
Ratio,
It's ratio. Why is it ratio?
because we can
Height.
perform
Can
all the
compare and
Because we can even say that, can we
Average
say
height.
that someone is twice as tall as someone else?
yes,
Yes, we can. Yeah?
yes.
Okay, it usually happens if we have a child and an adult, because an adult is very rarely twice as high or tall as the other adult. But basically it makes sense, especially if we have a child. An adult can be twice as tall, right? So which means division makes sense. So it's a ratio level. And exercise 4, a list of, part 4, a list of 10 bestsellers of 2019 in books.
Ordinal.
Professor, I have small doubt. Like we can also call as continuous data, right? That is ratio level.
Sorry, say it again.
Yeah, for ratio level, there is we can call it as continuous data. That is a discrete or continuous, right? There are, I have small
I
doubt.
don't think it's necessarily the case, because even in integers you have something is twice as big, twice as much, right?
Okay. Yeah. Okay, Professor. Yeah.
So if we list the 10 best books, what level is this?
Ordinal level.
Ordinal level, exactly, because we can tell that this is the best, that this is the second best, the third best, so we can order them, we can compare them, okay? But is forming the difference, does forming the difference make sense?
Ma'am, can you say what does it mean to have a clear
Level of
definition of zero
measurement, sir.
in part 2 and 3?
Sorry, say it again.
What does it mean to have a clear definition of zero? I mean, ratio levels have clear definition of zero, right?
Yes.
So how this thing correspond to part 2 and 3? Could you please explain this?
Yeah, so a teacher of a class of 6 records the percentage that each student got. Can it happen that a student got 0% on an exam?
Yeah.
Yes, test.
Yes.
Exactly.
Yes.
If someone doesn't have any mark, no point, he didn't even write anything, then get 0 mark, which is 0%. So that is the 0 point.
But height cannot be 0.
Yeah.
Practically not, but theoretically, or we can consider the 0 point as the shortest or smallest infant who has ever been born, let's say. We can set 0 there.
Theoretically, that's why I have confusion between point and 3. That's why I asked, because height can't be 0.
Yeah, of course, height can't be 0, but we can assign a 0 point. Let's say this is, or if we consider the adults, okay, so we set the 0 to the smallest or shortest adult, right? So we can say that is our starting point.
Oh, okay.
That's why it's better to call it starting point than 0 point, because it doesn't always 0. It's not always 0, which we call a starting point, right?
Okay.
One doubt, sorry. I'm hearing this nominal, ordinal, and interval ratio, these terms for the first time. So is there anything I need to go before the session, or did I miss anything, or is it something we already know?
Sorry, say it again, please.
I'm hearing these terms for the first time,
Yeah.
ordinal, interval, and these types of measurement. Is there any more books or something I need to go through before joining this session?
Hello?
It's the lectures, because
ఇది సెషన్ అవుతుంది ఒకటి డేటా సైన్స్
he holds the lectures, right? So you should attend the lectures.
Mail
Venu, can you please unmute yourself?
And also the reading is uploaded. I mean, ye put there the reading where you can find books. And this particular one is covered in foundations of, or what is the name of the book? It's in the reading sections. It's uploaded in the reading section. If
also data science.
Yeah,
reading. If you go to reading,
I attended the yesterday's session, but that was mostly on the matrix part, eigenvectors and all those things. And the readings also, I think it's big books, right? I have to go through all this, means it will take a lot of time. I started with the mathematics.
Vishnu, you can find those all the explanations in the Unit 1 lectures by Yi.
Yes.
Okay.
Yes.
Okay.
Yeah. But if that is not clear enough, you can read Principles of Data Science, the corresponding chapters in Principles of Data Science. This particular topic, which we have just been discussing, is in it. It is Principles of Data Science. It's not long. It's not long. Very straightforward, very understandable book. I really recommend this. Okay.
Thank you.
So this is what we had to cover from the first sheet. Now let's do.
So we have question 8 and 10 as the most important one.
Yes, the most important ones. Please go through the rest. Find the answers either in the Yi's lecture or in the book. But these two are the most important ones. So please expect these on the exam. It is not.
Thank you.
Okay, so these are not difficult questions. Please don't lose marks with these. Okay.
All right. Thank you, Professor.
Sure.
8, 9, 10, right, ma'am?
8, 10. 8,
Okay,
10.
Okay. Thank
But
you,
it doesn't mean that you don't need to go through the rest. But these are, you definitely remember, please.
Will you upload in solution of this part 1 and part 2?
Everything will be uploaded. Everything will be uploaded. So every support you will be given all the support which is possible.
Sorry, Aki, can you hear me? I think for the one I cannot remember who is that. I think the confusion comes from there's a lag between tutorial session and lecture session. So what now Aki is covering is tutorial 1. If you want to find my lecture, that is under unit 1. And yesterday the lecture I gave, that is unit 2. So we have a 1 week lag between lecture and the tutorial. Sorry, Aki.
It's okay, no problem. Thanks, Yi.
Okay, ma'am.
Thanks, Yi. Okay. So again, this is a tutorial part 2, meaning we had a online tutorial. I held an online tutorial yesterday and the day before yesterday, which are even uploaded, which you should attend one of them, not both of them, just one of them. And now we are covering the questions for which we didn't have time yesterday and the day before yesterday. So this is the part 2, tutorial part 2.
Yes.
Okay. But I will also give a tutorial tomorrow on campus. But I don't know who is grouped, which students are supposed to come to that particular one. Still there is some chaos with this on campus or online, or hopefully this will get clarified soon. But anyway,
practical.
Tomorrow do we have practicals, ma'am?
I think Yi, are you here? Yi?
Yeah, I'm trying hard to unmute myself. Sorry. Yes, tomorrow we will have. I made my announcement last night. I think according to university's message, any changes will be effective from next week. So for this week, we will follow our instruction I posted over the weekend. Okay, so tomorrow, check your personal timetable. If you have been scheduled a practical session, please do come. And a few students also have been given like Aki said, on-campus tutorial session. So if you are one of them, you should also come. Okay.
Okay, ma'am. Thank you.
So, are we able to get this online? The material that has been taught in the practical session or tutorial session, can we get them on Canvas? Because for those who are in still quarantine, are not able to come on campus.
Yes, the tutorial I gave the day before yesterday is already uploaded. I gave the exact same tutorial yesterday live, but this I will upload today. But those things are the same, so it's enough to listen to one of them because it's exactly the same. And this one is going to be recorded now, and this will be uploaded as well. So that's why I'm saying that every support will be given for you.
Thank you.
Regarding on campus and online as well, both.
And I'm also going to have a drop-in session today from 3 o'clock through MS Teams. Every Wednesday from 3 o'clock online.
Okay.
Through MS Teams, I have a drop-in session where anyone can come of you, anyone can ask any questions about the material. Any questions, anything you didn't understand, can ask me. Every Wednesday.
So, ma'am, basically drop-in sessions are doubt clearing sessions.
Yes, exactly. Yes. Drop-in
Okay.
sessions if anyone has any question, anything which doesn't understand, anything which would like to discuss or wants me to repeat a question or exercise solution.
Okay, ma'am.
It's for
Okay,
any-
just one more sentence. I think somebody just type in the chat box, ask whether we can record on-campus sessions. I think in my lecture, I mentioned that it can be difficult. Say, for example, for Aki's on-campus tutorial session, Aki usually like to do lots of writing on whiteboard. So that may be quite difficult to be captured by recording. But we will put solutions at the end of each week. So hope that can be of help. Sorry, Aki, back to you now.
No problem. Thank you, Yi. Thank you.
Okay, ma'am. Thank you.
Okay, so now let's continue with the tutorial 1 part 2. So the other sheet which we can find under unit 1.
Yeah.
Matrices and vectors, ma'am.
Sorry?
Matrices and vectors. Right?
Linear algebra. We just start with these vectors.
Yes, ma'am. Okay. Yes, correct.
Okay, so this is what we covered yesterday and day before yesterday.
Yes.
But we didn't do all the exercises. So is there anyone here among you who didn't attend either yesterday's or the day before yesterday's tutorial? Which means,
yes, ma'am.
which means it's completely new. Okay. Okay. So let's start with the exercise 1. We have the 2 vectors u and v. Okay. Yes. Calculate the following. In the first one, we need to add the 2 vectors. In the second one, we need to subtract the 2 vectors. When we are given, the components of the vectors are given. So how do we add and how do we subtract vectors? When the components are given. The components of the vectors are given. So we can see that u equals 10, 2, minus 6, and v equals minus 3, 0, minus 2. How do we add and subtract vectors?
Add corresponding elements.
Yes.
The corresponding elements to the 2 vectors.
Yes, we add the corresponding elements. So let me, or we subtract the corresponding elements if it's a subtraction. So yeah, let me do u minus v. Then we have, the result is a vector where the components are 10 minus 3, 2,
13, 2 minus 4.
minus 0, and minus 6 minus 2, right? This is the system. That is 10 minus 3, which means plus 3, it's 13. 2
13 2 minus 4.
minus 4. So this is the result of the subtraction. This is how we subtract two vectors.
Yes.
And if we add them, obviously we add the corresponding coordinates. Okay. Now the norm. Yesterday we calculated the norm of u. Now let's calculate the part 4, the norm of v. Norm of v.
Yeah, is the length of a vector.
Yes, the length of a vector, exactly, which we put, the notation is this double dash or double line. Okay.
Yeah.
How do we calculate that? What do we need to do?
We
Squaring
add all
the elements and adding
Square root
under square root.
of sum of squares of the
Square root sum of the and adding.
Yes,
and
exactly.
putting the under root over the whole procedure.
Yes, so we square the components, add them,
Yes, and under root
Taking
of
under root.
and the square root, under square root, yes. So we have minus 3 squared plus 0 squared plus minus 2 squared under the square root. So it's 9
13.
plus 0.
13, under root 13.
Very good. Square root of 13.
Yeah, correct.
Okay. We covered the distance yesterday, so all we do is just tell me what the distance is, of two vectors.
We add corresponding elements of the vectors and take the difference between them and the square root of the whole calculation.
Yes, exactly. So we form the difference. The first step is to form the difference of the two vectors, right? And then we have the difference vector and we calculate the norm of the difference vector, right? This is what we do. Okay.
Yep.
Though this is exactly what you said. Yes, exactly. What is we covered it yesterday, but it's very important. The inner product. What is the inner product of two vectors?
Scalar product.
Inner product. What is another name of inner product?
Dot product.
Yes.
Maybe scalar product.
Dot product.
Very good.
Scalar
Dot
product.
product. Dot product.
Scalar product.
Scalar product.
Thank you very
Scalar
much.
product.
Very important. Scalar product. Scalar. What is a scalar? What is another name of a scalar?
Scalar is a number.
Very good. A number. Exactly. Scalar or number, same thing, right? So
Yes.
why is the inner product? Why is it also called a scalar product?
Because it is one single entity.
Yes.
Because we get a single entity after computation.
Very good. So the result is a number. A result is a number, or with other words, a scalar. I'm emphasizing this because it's a common mistake among students that instead of a number, the result is a vector, right? Which is not correct because the result of the inner product is supposed to be a number, not a vector. Okay. How do we calculate the inner product?
We multiply corresponding elements and add them together.
Corresponding multiplying elements and adding them.
Yes, exactly. Very good. So we multiply the corresponding components and add that. So there is a plus sign addition between them, not a comma. Because if we put a comma, then we have three numbers, which means we have a vector with three components, which is not correct because we are supposed to get a number as a result, not a vector. Okay, so we have here 10 times minus 3 plus 2 times 0 plus minus 6 times minus 2, which is minus 18. Minus 18. And the question is whether these two vectors are orthogonal.
No.
They are not orthogonal. Why?
The dot product is not zero.
Equal to zero.
It is, yeah.
Yes, because the inner product is not zero. Very good. So please, first of all, expect this exercise in the exam. And if you find, you need to give me an explanation or conclusion. So after calculating the inner product, if you find that it is zero, then please write down this sentence that since the inner product or dot product, scalar product, doesn't matter how you call it, of the two vectors is zero, the two vectors are orthogonal. If you find that the inner product is not zero, then please write down that since the inner product of the two vectors are not zero, the two vectors are not orthogonal. Okay, so please write down this one sentence as an explanation or conclusion to get the 4 marks. Okay.
Okay, ma'am.
Then with matrices, in exercise 2.
Yeah, professor, I have small note like third part and fourth part. Norm of U and modulus of V have same process, same, right? Meaning same, right?
Say it again, please.
Yeah, third part norm of U, and
Yes.
fourth part modulus of V. Same process. Process is same, right?
Yes, exactly.
Just name. Okay. Even modulus of V also meaning norm of V, right?
Norm of U, norm of V. We calculated the norm of U yesterday. This is already uploaded.
Ma'am, so both are same, right? Both are same, right?
Yes, exactly.
Yeah, both the same procedure. Yeah.
Even modulus of V meaning norm of V, right?
Someone, those who are not talking to me, would you mute yourself? Guys, would you mute?
Srihari.
అసైన్మెంట్ అంటే జూమ్ లో అప్పటికప్పుడు విని 2 వీడియోస్ ఉంటాయి.
Would you mute yourself?
దాని మీద మన వ్యూస్ పెట్టి ఆ 5 minutes డిస్కస్ చేసి ఆ 5 members కలిసి డాక్యుమెంట్ వర్డ్ ఓపెన్ చేసి ఆ వ్యూస్ అన్ని రాసి పోస్ట్ చేయాలి. రైట్ అది మా టీమ్ రీసెర్చ్ డెవలప్మెంట్ తెలీదు అది ఎట్లుంటుంది అసలు.
Ranjit Kumar Kolomare, could you please mute your mic?
Okay.
Divya.
We can't continue until you mute yourself.
నేను వింటున్నా క్లాస్ కొంచెం ఏదో ఎక్కడ పేపర్లు ఉన్నాయి కొంచెం లైన్ లో పడినట్టు.
Tulasi Sai Ram Babu, please unmute yourself.
Just mute. Unmute now.
Yeah, professor. Is it audible now?
Okay.
Yeah, my question is like third part and fourth part is meaning same, right? Norm of U, that is in third question. Fourth part is modulus of V. Modulus of V, yeah, that is the meaning as norm of V, right? Same as
norm of V, yeah, which means the calculation is the same, but with two different vectors. We have 2 vectors. In question 3, we have U, so we have to calculate the norm of U, and in the part 4, we have to calculate the norm of V, but the calculation is exactly the same, right? Which means we square the components of the vector, we add them, and we take the square root.
Okay. For 3 and 4, both process is same.
The process is exactly the same. Yes, exactly the same. Yes. Okay. Yes. So exercise 2, when we have these matrices, we need to add and multiply matrices by a number or with each other. Okay. First of all, when can we add 2 matrices?
When they have same sizes. Same sizes.
Same size, exactly. Same size. They have to be the same size. That means both the number of rows and columns have to be equal. Yes. Another question, how do we multiply a matrix by a number?
We multiply every element.
Yeah, very good. So we multiply every entry of the matrix. This is how we. So let's do part 3, which is 2C minus D.
Yeah.
2C minus D.
Yes. 2C minus D.
4104208.
So we have 2C, which is, we just multiply every entry by 2. So we get 4104208. And we need to subtract D, which is 0511423, to get 4 minus 0 is 4, 5, 3
minus 2.
8 minus 3, right?
Yeah.
Which is 5. Yes. So this is the solution. Right?
Yeah, right.
Okay. Let's see the part 4, 2e plus d.
We cannot solve this.
We cannot add. We can easily perform 2e because we just multiply every entry by 2. But then, why isn't it possible to add matrix
So
D?
E and D have different sizes, different size of E and D.
Okay, so again, please, if you get this in the exam, write down your explanation that the two matrices can't be added because they are of different sizes. Okay, so please write down just very shortly this explanation, okay, to get the full mark. So always, if something is not possible to calculate, write down the explanation why, just shortly. I will understand. You know, don't need to write so many sentences. One sentence is enough. Okay. Now, let's go to multiplication, matrix multiplication. We did AB yesterday. What about, see, okay, so when can we multiply two matrices? What is needed to be fulfilled?
Number of columns should be equal to number of rows.
Columns should be equal to the number of rows.
Exactly,
Yeah.
Very good. So the number of columns, the first matrix has to equal the number of rows of the second matrix, right?
Yes.
Right? Because what do we do when multiplying two matrices? What do we do?
We compute dot product, scalar product.
Thank you
of
very
two.
much. This is it. Yes.
Yeah.
So what we do is we form the dot product or inner product
Yes.
of the row vectors of the first matrix with the column vector.
Column vector, second
of the
matrix.
second matrix, right? Because we multiply the corresponding elements and add them together to get a number, which is nothing else but the inner product of those two vectors, right? This is what we are performing. Which means that if a row vector of the first matrix happens to be orthogonal to a column vector of the second matrix, then what will be the dot product?
Dot product would be 0.
0.
Yes, in that case, the dot product is 0. Exactly. So let's do part 8, E times C, EC. So we have matrix E and is it possible?
No, it's not possible because the number of columns of the first matrix is not equal to the number of rows of the second matrix.
Which one is the first matrix?
We would consider E as the first matrix according to the question.
It's part E, part 8. Part 8
is possible, madam.
We have EC. What is the number of columns of E?
Yeah, EC product is possible because
EC product is possible, yes.
E is a 3 by 2 matrix, so the outcome of EC will be 3 by 2.
Yes, so the number of columns of E is 3.
Yeah.
And the number of rows of C is 3, which means it is possible. EC is possible.
Yes.
The other way around, CE, would that be possible? So
no, madam. No.
Well, so what can we conclude about the multiplying matrices? Can we swap the order?
We cannot swap the order because it is not commutative.
Very good. Thank you very much. So matrix multiplication is not commutative. That means that we can't swap the order because we either just don't get the same result or it's not even possible to multiply them in the other way around, right? So it's not even always possible to multiply them if we swap the order. And even if it's possible, in most of the times we don't get the same result. Okay, so we don't stop. So E times C doesn't equal C times E. So beware about the order. You have to do what you are given. So A times B, then you have to do A times B, not B times A. Okay, so be careful with this.
Okay, ma'am. Ma'am, solving the questions, do you really, the ones you can multiply by each other, writing a statement would just be enough? Would writing a statement just be enough that this can't, you can't multiply this maybe because they're not the same? they're not the same. You can multiply them. So we just writing the statement be enough.
Exactly, absolutely enough. So please expect in the exam matrix multiplication. Once, at least one where you are able to multiply, and when you are not able to multiply. If you are not able to multiply them, then you just write down the explanation, just one sentence, that these two matrices can't be multiplied because the number of columns of the first matrix doesn't equal the number of rows of the second matrix. And don't swap columns and rows, okay? The number of columns of the first matrix has to equal the number of rows of the second matrix. And if it is not the case, then it's not possible to multiply them. You just write down this sentence as an explanation and you get the full mark, right?
Okay, ma'am. Okay.
So EC, what we need to do is we just write them next to each other. So 1, 3, 2, 0, 1, 1, 3, 0, 2, and 2, 5, 2, 1, 4, 0, 4. Okay, so we are going to have a result matrix. What is the first row, first column element of the result matrix going to be? This will be the dot product of the first row vector of the first matrix with the first column vector of the second matrix. That is the first row, first column element of the result matrix, which means we have 1 times 2 plus 3 times 2 plus 2 times 0, right? This is the first row, first column element of the result matrix. Now the first row, second column element of the result matrix is the dot product of the first row matrix of the first matrix with the second column vector of the second matrix. So we have 1 times 5 plus 3 times 1 plus 2 times 4. Right? So I just write down. Yeah. I encourage you to write down these with these details. Because if you don't write this calculation down and you miscalculate it and you just write the wrong number, then I can't give you any marks. But if you write down this calculation that 1 times 2 plus 3 times 2 plus 2 times 0, even if you miscalculate it in the end, I can give you marks because I can see that you know how to multiply them, and it happens to everyone that miscalculates something. So I may deduct half of a mark, but you will get the majority of the marks, okay? But if I only see a wrong number, I can't give you any marks. So please give me a chance to give you marks. Okay. So what is the next? Drágám, órát tartok, mindjárt visszahívlak.
Mom, can you please share your notebook again? Can you please share your notebook again?
Say it again, please.
Can you please share your notebook again? Share your notebook.
Oh, yeah. So far, I have done the calculation of the first row element. And now I'm going to calculate the second row, first column element. Second row, first column element, which is the dot product of the second row of the first matrix with the first column of the second matrix.
Hello.
So we have 0 times 2 plus 1 times 2 plus 1 times 0. Now the second row, second column element of the result matrix is going to be the dot product of the second row of the first matrix with the dot product with the second column vector of the second matrix. So we have 0 times 5 plus 1 times 1 plus 1 times 4. Now, right? Now the third row, first column element of the result matrix is going to be the dot product of the third row of the first matrix with the first column of the second matrix. That is, we have 3 times 2 plus 0 times 2 plus 2 times 0. And then the third row, second column element of the result matrix is the dot product of the third row of the first matrix with the second column of the second matrix. So 3 times 5 plus 0 times 1 plus 2 times 4. Okay, so we have formed the dot product of the row vectors of the first matrix with the column vectors of the second matrix. Now we just have to calculate this. So these are going to be 8,
16,
16,
2,
2, yes,
5,
5,
6,
6,
23.
23. Very good. Thank you very much. Well done. Exactly. Okay, so again, multiplying two matrices is forming the dot product of the row vectors of the first matrix with the column vectors of the second matrix. And since multiplication of the two matrices are possible only if the number of columns of the first matrix equal
number of columns of second matrix.
Number of rows. That's why when we have, for example, we have the two matrices, and the size of the first one is m by n, right? Then the size of the second matrix has to be what?
N by k.
N by something, exactly.
Yeah.
N by, let's say, k.
K.
Right? So the two red ones has to be equal.
Yes,
so we are close to each other. It has to be equal, right?
Yes, ma'am.
And what is the size of the result matrix going to be?
It should be m by k.
M by k.
Yeah.
Exactly. M by k. That is the two numbers which are far from each other, right?
Far from each other. Yes. Yes.
Yes. Exactly. Okay. So this is matrix multiplication.
Okay.
We have. Now we have done it yesterday, but let's do just at least one. The inverse. What is, we need to find the inverse of a matrix, right? What do we mean by the inverse? Denoted by this -1 in the exponent, but it's only a notation. It means just the inverse of the matrix.
Transpose of the matrix?
Not the transpose. We have a transpose as well, but inverse. By definition, what does an inverse mean? Not only
with inverse will give you the identity matrix.
Yes, very good. Not only in case of matrices, but in general, if we consider the numbers, right? What is the multiplicative inverse of a number?
Reciprocal of that number.
Reciprocal, yes, very good. The reciprocal, for example, 5, its multiplicative inverse is 1/5. Right.
Then 1 by 5.
1 by 5 or 1/5 or 1/5, whatever we call it. But how do we know that should be? What is the definition? Of an inverse?
We will get 1 if we multiply them.
Very good, exactly. So when multiplying an element with its inverse, we have to gain the identity of that set, whatever it is. If we are talking about numbers, then the identity is the number 1. If we are talking about matrices, then the identity element is the identity matrix. Okay, but by definition, doesn't matter in what we are talking about, in what set we are. The inverse by definition means that an element multiplied by its inverse gives the identity element of that set. Okay, whatever set it is and whatever is the identity is in that set. Okay, but in case of matrices, the identity is the identity matrix. Okay, which means that if we have a matrix B, we have to find a matrix by which, when it is multiplied, we get the identity. If we have a 2 by 2 matrix, how do we find the inverse? Let's do B. So matrix B.
Multiply with the identity matrix.
Matrix B.
We calculate determinant.
How do we find the inverse? So we have matrix B.
We have to find determinant first.
Very good. 3,
Yeah.
6, 2.5, 2. Okay.
Yeah, then multiply with the matrix.
Very good. First, yeah, as you said, you have to find the determinant of the matrix.
Yeah.
The determinant of the matrix is, how do we find that?
It's AB minus CD.
Yes, you have to multiply the diagonal elements. So in this case, we have 3 times 2 and minus, we subtract the product of other diagonal elements. So 6 times 2.5.
15.
Which is 6 minus
6 minus 15.
Minus 9.
Minus 9. Yes. Okay, so this is how we calculate the determinant, as this is the first step.
Yes.
Now you said that if we have a matrix B, what is its inverse? What is the formula for an inverse? What do we need?
1 by determinant.
1 by determinant of matrix B into adjacent of matrix B.
Yes, so 1 by determinant. Basically, we divide by the determinant, but dividing by a number is the same thing as multiplying by its reciprocal, right? Multiplying by its reciprocal. And then we take the matrix and we swap the diagonal elements. So we have 2, 3, and we multiply by minus 1, the other 2 elements.
Yes.
Yeah. So in general, as you said, A, B, C, D, then A minus equals 1 over the determinant times A, B, C, D, D, A minus B minus C, right? This is the general formula, right? So to get the inverse, first you need to calculate the determinant, because then you have to divide by the determinant, right? Because 1 over determinant. What follows this?
Determinant should not be equal to 0.
Thank you very much. Very, very important. So what happens if the determinant is 0? What happens?
It's undefined.
Undefined or not defined.
Very good. So please note it very well that what is 1 over 0? What is this?
Undefined.
Not defined.
Very
Not
good.
defined.
Thank you very much. So very important that it doesn't equal 0 and it doesn't equal infinity. Okay, many students say that it doesn't equal 0 and it doesn't equal infinity. It is not defined or undefined. Okay, division by 0 is not defined. It's not defined. Division by 0 is not defined. It follows that if in the exam, if you get a matrix for which you have to calculate the inverse, first step, you calculate the determinant. If you find that the determinant is 0, then there is nothing to calculate any further. There is nothing to calculate any further because we can't divide by 0. Okay? So please don't write such thing that the inverse is 1 over 0 and you write some matrix. So this is not correct because 1 over 0 doesn't exist. So it's not correct. Please don't write such thing. Don't write such thing. Okay? So again, if in the exam you find that the determinant of the matrix is 0, then you just write down the sentence. Since the determinant of this matrix is 0, its inverse doesn't exist. the inverse doesn't exist. Full stop. And you get the full mark, the full marks. You get the full marks, okay? But please don't write such thing that 1/0 times the matrix, because it's not correct, it's nonsense, right?
Yeah.
But you need to write down this explanation. It is one sentence, just one sentence. Okay. So in this case, a case with
I'm sorry.
matrix
Are
B.
we able to calculate determinant for 3x3 matrix?
So, say it again, please.
Are we able to calculate determinant for 3x3 matrix?
Yes, we are.
Can you please show me if yes? How can we do that?
Yeah, we'll do that with the zeros. Okay, so you understand how to do this. Okay, let me show you.
0/1 is infinity, right?
0/1 is 0 divided by 1 is what?
0.
0. Yeah, 0 divided by anything is 0. So that is defined, makes sense. It's always 0.
Except 0, ma'am. 0/0 is infinity, right?
No.
That doesn't make sense because we can't divide 0.
0/0 is 0.
0/0 is no. Oh,
Aggie,
yes.
I'm sorry, to interrupt. You need to be careful your time. You have another session, drop-in session.
All right, all right.
Yeah.
Okay, so I need to finish now, but you can join me with the drop-in session. I will open it on in MS Teams now.
Okay, ma'am.
Okay, so please attend in one of the tutorial part 1, which was yesterday and day before yesterday, but you can watch the video online because it's already uploaded.
Agnes, one more thing. How can I join the drop-in session? Is there a team ID that I need to join?
Yes, the link is there. The link is on the, let's...
It's in the unit, I believe.
The unit page under the, at the bottom, almost,
Yeah, it's under unit.
I just see one sentence. There's someone actually left a message asking about a practical session tomorrow. If some of you are still in self-isolation, okay, please stay in your own accommodation. What we are going to do is tomorrow for practical session, we cover the first 5 questions in the practical handout. So you can do it on your own at home. But if you have any questions about those 5 tasks, please come to drop-in session on Friday. Chloe, she's one of those tutors responsible for practical session. She's very experienced. So if you have any questions, you can bring your question to that drop-in session. And at the end of this week, we will also put solutions online so that you can check. So I hope that can help those who are still in self-isolation. Okay, so sorry, Aggie.
It's okay. Okay, guys, so I need to go now to start my drop-in session. So whoever wants, please join. And this, I will run it every Wednesday from 3 o'clock. Okay, and please keep checking your emails about updating, because he keeps sending you emails about...
Not emails, announcements.
Announcements. If any information she gets, she immediately sends the information for you. Okay, so please.
Quick question.
Yeah.
Will going through the tutorials and getting to understand the tutorials properly, would it be sufficient for me to pass the exams?
You mean, so you're asking whether the material covered by the material covered by in the tutorials is enough for the exam? This is what you're asking?
Yes, is the tutorial materials, studying them properly, would it be enough for me to pass the exams?
It is very important part, but you need to do some practical. So, Yi, are you here?
Yeah, I think Daniel, did you ask this question?
Yes.
Yeah, so
Yes.
so I asked, for the previous years, I asked students, for the tutorial questions and the homework questions, each question at least do twice, okay, before you attend the online test. And we also have practical session related questions. You need also finish all those tasks set in practical handouts on your own. Then you should be able to pass. Okay.
Okay.
Okay, ma'am.
Yeah. So
Doing the tutorial questions and answering the practical questions, I'll be able to pass the exams.
You know, for those tasks for practical session, you need to understand the outputs. Okay. Yes. Okay.
So, Professor, tomorrow we don't have any.
Everyone, we have to leave because Agi has another session. Someone maybe is waiting for her in drop-in session. So join her in the drop-in session. Okay. If you have more questions for me, put on the discussion forums. Okay. Thank you.
Thank you.
Thank you, ma'am.
Thank you, ma'am.
Bye.
Thank you, ma'am.
Sure. Bye-bye. Bye-bye.
Thank you very much.
Sure.
Bye, ma'am.
Bye-bye.